Hello.
Hi, Kayla.
Hello.
Hi, Ben.
You seem it's a bit louder.
I'm louder.
I think. Yeah, I think.
Could be my speaker. Is that better?
Slightly, yeah.
Or maybe it's your speaker. Could be your speaker. I'm not sure.
My computer is now at one sound, so hopefully, hopefully that helps.
All right. Well, I'm going to pick up where I left off last time. Get this out of here. Let's see, because we had gone over intervals, and then there was this page that showed all the different types of intervals. And then I took inequalities and transferred them to intervals. And then here was their explanation. And now we're getting ready to go backwards. So I'm going to try to finish up 1.5 and hopefully get through all 1.6 today, but we will see how it goes. So,
Do we have a test next week? And if we do are we going to have a review page?
No, you don't have a test next week. We have to still cover section 1.7, and then there's kind of a review. There's only going to be 2 exams in this class, a midterm and a final.
All right.
That's it. The midterm, that's a few weeks away. I can't remember off the top of my head when it is, but it's not next week.
Okay, thank you.
Okay, so we're going to write each interval as an inequality solving for x. Now, they did not ask me to graph this, but I'm a visual learner. And so when I see, let me just get my black pen here. When I see on part A, it goes from 1 to 4. There's a bracket on the 1, and there's a parenthesis on the 4, and it's everything in between. So I see this as what I call an in-betweeny. So x is in between the 1 and the 4, but because there is a bracket on the 1, I need a less than or equal to sign. There's only a parenthesis on the 4, so I just need the less than sign. So this is the answer to part A. Okay. Now part B has a 2 and then an infinity. So let's say here's the 2 for part B. There would be a parenthesis here for the 2, and then it's going to infinity, which would be in this direction. And so when I see this, I see x is just greater than the 2. That's what I'm seeing. This is part B. It starts at 2 and it goes to infinity, so x can be anything greater than 2. Now on number C, or letter C, I have a 2 going to a 3. So here's 2, here's 3. There are brackets on both of them. So it starts at 2 and it includes the 2, and it goes to 3 and it includes the 3, and it's everything in between. So it's an in-betweeny. So here's x, which would be in between 2 and 3. And because they are both brackets, I need less than or equal to signs. So that's the answer to part C. And then on D, it starts at negative infinity, which would be, you know, this way, going that way. And it comes up to negative 3. And then they have a bracket on the negative 3. So my graph would look like this. Negative infinity up to the negative 3. So this is really saying that x is less than or equal to the negative 3. Anything I've highlighted is what x can be. And since that's starting at negative 3 and going to the left, it's less than. It's less than or equal to. And even this arrow is pointing to the left. Whereas on part B with the green arrow is pointing to the right, so it's greater than. And like I said, you don't have to graph these to do them, but it gives me a visual and I can get a better grip on what I'm looking at there. Questions on that? And then here's their answers. Okay, so we are now going to move on to solving inequalities. Okay, the steps that you take for solving an inequality are the exact same steps that you take if you're solving an equation. It's just that there's one extra step, and that would be this step right here. Or this one, actually. When there are times when you will have to reverse the direction of your inequality symbol. The first one is if you switch sides. So here it says 3 is less than x. If you switch the 3 and the x, and you put the 3 on the right and the x on the left, you also have to switch the inequality. Because if you're saying 3 is less than x, that's the same thing as saying x is greater than 3. So if you switch sides, switch the sign. Now, the other one, which is not as easy to remember, I think the first one makes sense, but whenever you divide or multiply, and that's what it says right here, if you multiply or divide both sides of the inequality by the same negative expression, you're going to have to reverse the sign. And so they're dividing both sides by -2, so you'll notice that the greater than sign got switched to a less than sign. And I'll show you why. Let's say I just had a true statement of x is greater than 4. That's a true statement. If I divide both sides by -2, 8 divided by -2 is -4. 4 divided by -2 is -2. If I leave that greater than sign, it's not true anymore. -4 is not greater than -2. It's actually smaller. For some reason, when you divide or multiply by a negative, it jacks up the inequality, and you have to remember to switch it around. I can see it there because it's just nothing but numbers, but over here I'd have x is less than -3 when I do the division. You don't really see it because of the x, but here I can see, yeah, -4, that's not greater than -2. And I'd be like, oh yeah, I forgot to reverse the sign. So unfortunately, number 2 is something you're going to have to remember to do. And most of the time when you're solving an equation, you usually wait, and then that last step is to divide off a negative coefficient. Sometimes you have a negative fraction and you multiply by the reciprocal. So that's why they include multiplication, multiply or divide by a negative. So here is an example. It says just solve the inequality and graph the solution set. So if I were going to do this, I would start by subtracting 2x on both sides, cancels out there. 4x minus 2x is 2x, plus 7 is greater than or equal to a -3. My next step would be to subtract 7. Now, adding or subtracting with a negative doesn't mess up the inequality. It's only multiplying or dividing. So that cancels there. I'm still going to keep the greater than or equal to sign. And then -3 minus 7 is a -10. And then the last step is to divide by a 2. I'm dividing by a positive. That will not mess up my inequality. Even if you're dividing into a negative, it's what you're dividing by. I'm dividing by a positive. So my answer is still good, or my inequality sign is still good. So here's my answer. And then they want me to graph it. So I got to draw a number line. Here's -5. Down here would be -6. Up here would be -4. It's an equal to, so I'm going to need a bracket on the -5. And then it's greater than, so the bracket has to be bracketing in the greater than direction. The little lines have to be going in that direction, and then draw an arrow in that direction as well. And that is the graph. Now, I didn't have to divide by negatives, so I didn't have to reverse my sign. I didn't have to switch my x on either side. So And then I left the slide in here where they show how they did it. And they subtracted 7 first, and then they subtracted 2x second. I don't know why they do it that way. I subtracted the 2x first. I'm solving for x, so that's what I focused on was, hey, get rid of one of those x's. But you can still see it's the same answer. Did they ask me to do interval notation? No, it just says solve the inequality and graph the solution set. But if you look down here, first they put it in that nasty set builder notation, and then they also wrote it in interval notation here. So do whatever my math lab asks you to do, how they want you to type in the answer. And if it's a graph, more than likely it'll be multiple guess. All right, now, combined inequalities, or as I like to call them, the in-betweenies. Because it says -5 is less than 3x minus 2, which at the same time is less than the 1. This stuff here is in between this and that. It's in between two numbers. So when I solve these, I solve both ends at the same time. Instead of, my math lab might have you split it into two separate inequalities, but that's a lot of extra work that you don't need to do. So I'm trying to get x in the middle right here. I want to know what number is less than x, which is also less than what number. I want x by itself in the middle. That's what I'm going for, is just an x. I don't have just an x. I have a 3x minus 2. So I am going to add 2 to this so that it cancels out. But I also have to add 2 to both ends. I got to add 2 to this end and add a 2 to that end. So now I just have the 3x in the middle, getting closer to being just an x. Let's see, 1 plus 2 is 3 at the right end, and -5 plus 2 is -3 at the left end. And now I would divide this by 3 to cancel it out, and boom, there's the x right here. X is by itself in the middle, but I have to divide both ends by 3 also. And now I can erase these question marks. 3 divided by 3 is 1, and -3 divided by 3 is -1. And of course, here's that x. That's my answer. X can be any number between -1 and +1, but it cannot equal -1 or +1. And they want me to graph the solution set, right? Graph the solution set. So on a graph, here's -1, here's 0, here's 1. I need a parenthesis on the -1 and a parenthesis on the +1, and they have to, you know, be curving towards each other so that you can highlight everything in between. That's why I call it an in-betweenie. If they want it as an interval, it would be parenthesis, -1, comma 1, parenthesis, if they wanted an interval notation. And then I left their slide where, okay, they divided it up into two separate intervals. They're like, I don't know how to show this. They took this side here and wrote it as one equation. And then they did this side here and wrote it as a separate equation. Okay, I mean, it works. And then they solved both of them separately. So this one is the blue one, they did all that work. And then this one is the green one, they did all that work. And then they had to put the two back together again here. I mean, it works, but I feel like you're doing a lot of extra steps there. So I like my method better. But whatever makes you feel comfortable and gives you the warm fuzzies, you can do it either way. Doesn't matter. Okay, so that takes care of the lecture part. So the rest of my PowerPoint, I literally just took screenshots of my math lab questions and go through them. That way you've got examples of them when you are doing your homework. So number 3 says, express the graph shown in color using interval notation. So they want this as an interval. And you can see that it starts at 6 and there's a bracket. So you're going to go bracket 6, comma, and then the arrow keeps going this way, which means eventually it would be to infinity. And remember, infinities, positives or negatives, always you use a parenthesis on that. So this is my answer that I'll put right in here. And then it says the graph represents the inequality. Well, everything that is highlighted is what X can be. So X can be greater than or equal to 6. Again, you're starting at the 6 and then you're going to the right. So anything that is 6 or to the right, that's greater than. And so this answer is what would go right here. And that's number 3. Let's see, 4, they give me an inequality. It says, write the given inequality using interval notation and then illustrate it on a number line. So there's 2 parts. You'll see this part first. This will pop up first. You'll have to enter your answer. Get your positive affirmation. Good job. And then the graph part will pop up and you pick the correct graph. So on an interval, remember you don't use X's on the intervals, you only use numbers. And this guy is an in-betweeny. It goes between 3 and 7 and they both have equal to's. So I need brackets on either end. And then I pick out the graph and that would be C because it's from 3 to 7 and everything in between. Remember, the intervals go from start to end, starting point to ending point, and then anything in between. Here's another one. Now this one involves infinity, negative infinity. So you're going to have an arrow at one end and it should be pointing at negative infinity. And remember, on a number line, if you're looking at it, negative infinity is this end, positive infinity is at that end with the arrows. I have horrible arrows today. So it's going to start at negative infinity and then go up to the 4, but don't include the 4. So that would be choice B. And I just realized I was looking at the graph first. Sorry. They want the inequality for that. That would be X is less than 4. X is less than 4. You'd start at 4 and go to negative infinity. So that's from 4 and going in this direction. Number 9. Okay, now we're going to solve. And I can already tell I'm going to have to divide by a negative because there's only one X in the equation and it's a negative 4X. So my last step will be divide off that negative 4, which means I've got to remember to reverse my sign. So first step is get rid of that 1. I'm going to take 1 minus 1 to cancel it out, and then I'll have to subtract 1 on the other side. That cancels. I'm left with negative 4X is less than or equal to negative 15 minus 1 is a negative 16. And then at this point, I'm going to divide by negative 4. And that's when I have to remember, ooh, I just divided by a negative. So my less than sign becomes a greater than sign. And don't forget the equal to. And negative 16 divided by negative 4 is positive 4. And then it says they want all three ways to write this. Express the solution in set notation. So this is set builder. They already have the braces for you and the x such that all you're going to have to do is type in the x is greater than or equal to 4. The solution, oops, come on, pen. There we go. Now they wanted an interval notation. So as an interval, it's going to start at 4 with the bracket, comma, go to infinity, and close with a parenthesis. And then I just have to pick out the correct graph, and it should start at 4 with a bracket and go to infinity, and C is the correct choice. That's a bracket right there at 4, and it goes to the right. Sorry, that was my daughter. She was going out the front door, going for a run. Questions on that? Okay. And then the equations just, or inequalities, just get a little bit more complicated. This one has parentheses, so the first thing I'm going to do is distribute. Negative 2 times 3x is a negative 6x. Then you take the negative 2 times the negative 4. That makes it a positive 8. And then you still have less than 14. And now I'm going to subtract 8 on both sides. That cancels. Remember, subtracting a negative or adding a negative does not mess up the inequality sign. So I'm still going to have the negative 6x is less than 6. Come over here. Then I'm going to take the negative 6x and divide by negative 6. And because I am dividing both sides by a negative, this is where I have to reverse my sign. So I get x is greater than negative 1. And then it looks like the first part, they give it to you in both. They're giving you interval notation, or sorry, set builder notation, set builder notation, set builder notation, set builder notation. And of those, greater than 1, that one's out and that one's out. So it's either A or C, but I then have to look at the interval notations. Those are intervals, and it does not have an equal to, so this one has a bracket on it, so that one's out. So it's A. From negative 1, it's greater than negative 1, so it starts at negative 1 and goes to infinity. And that picture would be choice B. That's negative 1 right there. There's your parenthesis, and it's going towards infinity. Am I going too fast? Am I going just the right speed? I can go faster. Your silence is very reassuring.
You're
Y'all
good at
still
this
there?
speed. That's all right.
Good speed? All right.
Yeah.
Oh boy, fractions. Okay. I have a set of parentheses right here. So I'm going to distribute the 1/6 to the x. That's going to be 1/6 x. Then I'm going to distribute the 1/6 to the 15. And that would be, and I'm just going to leave it as 15/6 is greater than x plus 20. Now the reason I left it as 15/6, little fraction review here. If you have 1/6 times 15, that's the same thing as 1/6 times 15 over 1. And then it's just numerator times numerator over denominator times denominator. Now I could have reduced it. Technically that does simplify by 5 and simplifies by 3. 3 goes into 15 5 times, 3 goes into 6 twice. But my next step on this is I want to get rid of my fractions. I don't like working with fractions if I can avoid them. And since this is an equation, what you do to one side, as long as you do the same thing to the other side, you can do whatever you want. And so what I am going to do is I am going to multiply both sides by 6. Because when I distribute the 6 to the 1/6, 6 times 1/6, the 6's just cancel out, and I'm just left with 1x. When I take the 6 times the 15/6, same thing. The 6's cancel out, and I'm left with the minus 15. And then I got to distribute the 6 over here, so I get 6x plus 120. And that just makes it a little easier to solve if you just kind of clear out the fractions. You don't have to. If you want to work with the fractions, you may do so. Okay, I like to get rid of my smaller x, so I am going to subtract 1x on both sides. That cancels that out, and I've run out of room, so follow me. That's going to give me negative 15 is greater than 6x minus 1x is 5x plus 120. Next, I'm going to subtract 120 from both sides. Boom, that cancels. Negative 15 minus 120 is a negative 135, which is greater than 5x. And then I'm just going to divide off the 5. I'm dividing by a positive number. It's not going to mess up my inequality. The 5's cancel. There's an x. And then negative divided by positive is a negative. Grabbing my handy dandy calculator. Turn it on first, April. That might be helpful. 135 divided by 5 is 27. Now, this says negative 27 is greater than x. But when I look at my choices for my inequalities down here, none of them say negative 27 is greater than x. They all have the x first. So I have to look at this and remember rule number 1. Let me go back and find it. Where was it? Boop. Number 1, if you interchange the two sides of the inequality, then you have to reverse the sign also. So if I want to put the x on the left, if I want to put the x over here and the negative 27 on the right, then I have to reverse my greater than sign to a less than sign. And now I've got the correct answer. So x is less than negative 27. There's only one, it's A. This is greater than 27, greater than negative 27, less than 27. It's none of those. And then of course, this would be the correct interval notation as well. So the correct graph has to start at negative infinity and go up to negative 27, but don't include it. That would be this one here. So it's starting at negative infinity down here, comes up and includes that. That was fun. Look at all that pretty work. Oh, an in-betweeny, yay. Okay, if you don't mind, I'm just going to solve it my way. I'm not splitting into two separates and then have to come back because it's going to be an in-betweeny when I'm done. So I am going to rewrite it though, so it's a little bit more user-friendly for when I'm solving it and drawing on it. Okay, so I'm going to start with, remember you just want the X in the middle. So I'm going to get rid of the minus 15 by adding 15. But you got to do it at both ends. It's kind of like burning the candle at both ends. So I'm going to have 15 is less than or equal to, all that's left in the middle now is the 3x because I got rid of the minus 15. And 6 and 15 is 21. And now I'm going to divide off the 3 so that that cancels. But I got to divide 3 at the left end and divide 3 at the right end. 15 divided by 3 is 5, less than or equal to, I've got nothing but x in the middle. And 21 divided by 3 is 7. So this is my inequality. The solution is expressed in set notation, so what I just circled here is going to go right here after this line. And then in interval notation, they want interval notation. So in this box here, it's going to go from 5 to 7, right? 5 to 7. Everything in between, and because these are both equal to's, these have to be brackets. And then I'm looking for the graph that goes from 5 to 7 with brackets on both, and that would be this one right here, 5 to 7, everything in between. That's choice A. And I got one last My Math Lab question. Ooh, fractions. It's another in-betweeny, but it's got fractions in it. Okay. All three of my denominators are different. One's a 4, one's a 5, and one's an 8. You're only allowed to multiply by one number and one number only. And it has to be a number that 4, 5, and 8 can all cancel into. Well, let's see. 4 goes into 8, but 5 doesn't. And 5 and 8 both go into, well, 5 times 8 is 40. So 40 is my magic number. Okay, let me rewrite this. I'm going to take the 1/4 and multiply it times the 40. And then I'm also going to, I guess I meant to do this in color, sorry. I'm also going to multiply the middle guy, the x plus 1 over 5 times 40. Oops, that's just less than, sorry. And I'm also going to multiply the 5/8 by 40. Okay. And keep in mind, these are your inequalities. So it makes it an in-between. And what's going to happen next is, let me use gray for this. This 4 is going to cancel into that 40 10 times. And then 10 times 1 makes this 10. Now I'm going to go and do the other end before I do the middle. The middle is the most complicated. This 8 will cancel into this 40 5 times, and then 5 times that 5 makes this a 25. Now, the middle. This 5 is going to cancel into this 40 8 times. but I have to then distribute the 8 to both the x and the plus 1. 8 times x is 8x. 8 times 1 is 8. And now it looks very similar to, you know, the last one I did. So I'm now going to subtract 8 from both sides, and then subtract 8 from all 3 sections, and then divide by 8 in all 3 sections. So let me pick another color. How about blue? So I'm going to subtract 8 from the middle so that that happens. But I got to subtract 8 from the left end and subtract 8 from the right end. So follow me. Come over here. Let's see, 10 minus 8 is 2. I still have my less than or equal to sign, and I have an 8x left in the middle, and my less than, and 25 minus 8 is 17. Keep in mind, here's my inequality signs. They're kind of separating my sections. And now I'm going to divide off the 8 so that that cancels, leaving me with just x in the middle. But I have to divide 8 on the left end, and I have to divide 8 on the right end. Now, 8 does not divide into 2. So you're just going to leave it as a fraction, but I can reduce it. 2 8ths becomes 1/4. I have an x in the middle. And 8 doesn't go into 17 evenly, and it doesn't reduce, so I just leave it as 17/8. This is my answer, which when I come over to my choices, I need, let's see. This one says 1/4 x is less than or equal to x is less than 17/8, and so does this one. 1/4 is less than, okay. So it's going to be an interval, just going to decide it. If I wrote this as an interval because of the equal to here, I would need a bracket. And then this one's just a less than, so I need a parenthesis. And then of course you'd put the 1/4 here and the 17/8 there. So that would be this one. So it's D. And then I just looked for the graph that looks just like that too. Bracket to parenthesis, bracket to parenthesis. This one is a bracket to a parenthesis, and so is this one, bracket to parenthesis. However, both of these numbers are positive. This is a positive 1/4 and a positive 17/8. If you look at choice D, here's 0, and it's to the left of that. So these would be negatives. So it's got to be choice C, positive. And that's the end of section 1.5. Questions before I open up the next PowerPoint?
None from me.
Cool. Okay, looks good. Anybody else? Okay. Let's see. So going to 1.6. Let me share the screen. All right. If I don't get through all this, we will, finish it up on Monday with 1.7. So, excuse me. All right. Section 6 covers, the objectives are, we are going to be dealing with both equations and inequalities, but they will now involve absolute values. Okay. So we're going to start with solving equations involving absolute values. Now, if A is a positive real number, and if U is any algebraic expression, then the absolute value of U being set equal to A is actually equivalent to U equaling A or U equaling negative A. For example, if I asked you to find the absolute value of 5, the absolute value of 5 is 5. However, the absolute value of negative 5 is also 5. So when you solve an absolute value equation, there's going to be two possible answers, the positive and the negative value, because what's inside the absolute value could have been positive or negative before you took the absolute value. So I went straight to a couple of my math lab examples on this one. It says solve the absolute value equation. You're trying to figure out what X is. If they tell you that the absolute value of X is equal to 10, that means that this X right here could have been a 10 because the absolute value of 10 is 10, or it could have been a negative 10 because the absolute value of negative 10 is 10. So my two possible answers are this negative 10 and this positive 10. That's what I'm going to put inside here. Negative 10, comma, positive 10. Simplify your answer. Use a comma to separate answers as needed. Love you. Teaching class, they can hear you. Now, some of these get a little bit more complicated. The absolute value of 8x plus 2 is equal to a 5. That means that the stuff inside could have been a 5 or it could have been a negative 5 before you took the absolute value. So you're gonna take the 8x plus 2 and you're gonna say, okay, maybe that's a positive 5, or the 8x plus 2, maybe it equals a negative 5. You're trying to figure out what value for X. When you put that value for X right here, multiply it by 8, add it to 2, and then take the absolute value, it'll give you a 5. Or if you put it here, multiply 8, add it to 2, and it gives you a negative 5. It's one or the other. So solve each of these for X. I'm going to subtract 2. That cancels. I get 8x is equal to 5 minus 2 is 3. And then I'll divide off the 8 to cancel that and give me x. Then I got to divide this by 8. So one possible value is 3/8. If you were to stick 3/8 in here, 8 times 3/8 would be 3. 3 plus 2 is 5, and the absolute value of 5 is 5. But I also have to solve this one. That cancels. Negative 5 minus 2 is negative 7. And then divide by the 8. So that cancels. And I get x is equal to negative 7/8. If you were to take negative 7/8 and plug it in here, 8 times negative 7/8, the 8's cancel. I get negative 7 plus 2 is a negative 5, but the absolute value of negative 5 is also 5. So they both check. So inside here, I'll choose choice A and simplify your answer. Both of those fractions are in simplest form. Use a comma to separate them, and I like to put them in numerical order. So I'd put the negative 7/8 first and the 3/8 second. I don't think my math lab cares about things in numerical order. That's just me being, obsessive compulsive. That's what I do. Okay, and one more. This one, before you can split it into two absolute values, the absolute value has to be isolated. Just like when we were working those radical problems, the radical had to be by itself before you could square it off or cube it off or fourth it off, Same thing here. you have to get the absolute value by itself. That +2, this +2 right here, he is not inside the absolute values. My absolute values are right here. That +2 is outside of it. So I'm gonna subtract his ass off. Cancel him out. I'm still gonna have the absolute value of 2 minus 3t, but now it's gonna equal 14. And then this is where you split it into two. Either this 2 minus 3t equals a 14, or it equals a negative 14. The stuff inside the absolute value is either going to be a 14, or it's going to equal a negative 14 before you take the absolute value. Because then after the absolute value, they'd both be positive. When I saw both of these, I'll know what value of t makes that happen. So I'm going to subtract the 2. Boom, cancels that. I get negative 3t equals 14 minus 2 is 12. And then I'll divide by the negative 3 so that that cancels. So my first value for t is negative 4. That's one of them. And then I'll come over and solve this one. I'll do the same thing. I'll subtract 2 to begin with, except this time the negative 3t will equal negative 16. I'll still divide by negative 3 so that negative 3 over negative 3 cancels, and I get t is equal to 2 negatives will at least make it a positive, and then I'm going to leave it as 16/3 because it doesn't go in there. And then I'm sure my math lab has the exact same, where was it? Yeah, it's going to have these same choices of A and B. The solution set is use a comma to separate your answers. I didn't screenshot that on this problem because I knew I was going to need a little bit more room when I was drawing. So, but you'll be like the set of -4, comma 16/3, and then whatever bubble dot you have over there. So now that's absolute value equations. Now we're going to do the inequalities, and these are a little bit more complicated. So I'll let you take a breath for a minute. Over the weekend, I drove up to Indiana Dunes, way at the top of the state of Indiana, Lake Michigan. It was for a few days. It wasn't too bad. The waves were pretty bad on Saturday, but Sunday they were pretty good. So, all right, inequalities. Okay. Solve an inequality involving absolute value. They want you to solve this one. It says the absolute value of x is less than 4. And here is their solution. We are looking for all points whose coordinate x is a distance less than 4 units. Absolute value is actually a distance. So if I were to say the absolute value of 4, that equals 4, because if you're at 0, you're 1, 2, 3, 4 units away. But if you're looking at the absolute value of -4, that is also 4, because from the 0, you are 1, 2, 3, 4 units away, just in an opposite direction. Now, if you want any value of x that is less than 4, it's going to be any of these numbers in here, and also any of these numbers in here. It's an in-betweenie. When they say less than, it's actually an in-betweenie, because it's going to be anything less than 4 or anything less than -4. Can you see that? You simply have to remember that when they ask you for, if they give you an absolute value inequality that involves a less than, that is going to be in between those two numbers, 4 and -4. And they even have a little theorem here. It says, if you have the absolute value of u is less than a, then that's going to be equivalent to u being in between a and -a. -a at this end, +a at that end. And the same thing works for less than or equal to. They just have the less than or equal to's here. And it'll always be in between. It's an in-betweenie. So absolute values that are less than something ultimately end up being an in-betweenie. So if they give you this one, solve the inequality, I can set this up in my mind and I'm like, okay, that 2x plus 4 is gonna be in between the 3 and the -3. It's an in-betweenie because it's less than. It's somewhere in between -3 and +3 because those numbers from -3 and +3 go to 0, anything less than them. So I would solve this just like I did before. How did they show it? They showed it the same way I would do it. They subtracted the 4 and then they divided off the 2. Yep. And then they wrote it as in set builder notation or in interval notation, and then here's the graph. So that's how I would do it too. So I'm going to do a couple of them straight out of my math lab now. Let's see, this one's really easy. Just says solve. The absolute value of x is less than 1. And you can see over here, they've already got it set up for you as an in-betweenie. All you have to do is put in the -1. Oh, heck, look at that. They've even got the negative sign for you. Gee, you think they'd go to the bathroom for me too? Wow, look at that. I just need to put the ones in there because they have the negative there for me. Okay, that's just a little bit too much. All right, this one, I'm gonna have to do a little work. Solve the following and then graph it. So I did 2 slides for number 10. Here's number 10 and here's number 10 continued. So you can see the multiple guesses on that. But I have to solve this. And first things first, your absolute value is not by itself. That rule has to apply here as well, whether they're equal signs or inequalities. Absolute value, got to be by itself. So I'm going to subtract 6 on both sides, so that cancels out. I'm going to have the absolute value of an x minus 2 is going to be less than 7 minus 6 is 1. So this is going to be an in-betweening. You're going to take the x minus 2, and it is going to go in between the 1 and the -1. Here's my inequalities, okay? The x minus 2 is in between 1 and -1. And now this one's going to be easy to solve because all I have to do is add 2 to cancel that out in the middle. But then you got to add 2 to the right end and you got to add 2 to the left end. So -1 plus 2 is 1 is less than x is less than 3. Okay. Let's see. A says there are finite many solutions. B says there are infinitely many solutions. And C says there's no solutions. Now, you might look at this and say, well, that's finite. No, it's not. There's actually an infinite number of numbers between 1 and 3, not just the whole number 2. You got 1 1/2, 1 1/3, 1 1/4, 1 1/5, 1 1/6, 1 1/7, 1 1/8, 1 1/9, 1 1/100, 1 159. I could go on all day. So it's actually infinite. And then the solution set, it does say here to type your answer in interval notation. So my interval is what I'm going to put here, and that would be from 1 to 3 with parentheses. And then the picture of the correct graph is 1 to 3 with parentheses. That'd be B right here. It goes from 1 to 3 and everything in between. Kind of looks like a one of them little flying things from the first Star Wars movies. I don't remember what they're called. Still made a lot of noise. Okay, so that's for less than. Now the next one is greater than. Okay. If it's greater than, then it has to be going in the opposite directions. Before less than was everything in between like this, okay? If you have an absolute value that's greater than, now it's going this way and this way. It's like on opposite ends. This would be two separate inequalities. It is not an in-betweeny, and you'll notice they even use the word or on these. If the absolute value of U is greater than an A, then that means that U, let's see, U is going to be less than negative A. That's this one, right? This would be going in the less than direction. So U would have to be less than negative A, or U is greater than A, and that's this one going in this direction. The same thing works for the equal to ones. This is a little harder because you have to remember it's still going to be negative A and positive A, but for the negative A, it's less than. For the positive A, it's greater than. And if you look at the original problem, it does say greater than A. That's this part, greater than A. You then have to remember, okay, the less than is going to be the negative A. So 2x minus 5 is greater than 3. I am going to split this into two equations. I am going to start with the first one, which says the 2x minus 3 is, come on, pen, is greater than 3. That's your first equation. Or the 2x minus 5 is going to be less than negative 3. So over here, I've got this one. Right? It matches exactly what I have. And then over here, you're still going to have 2x minus 5, but, sorry, I forgot to highlight my greater than sign here. On this one, you have to remember to reverse the inequality and also reverse the sign to negative 3. And now you've got two equations you have to solve, okay? On this one, I would add 5 to both sides. That cancels. I get 2x is greater than 8, and then 2 goes into 8 4 times. So for this one, x is greater than 4, x is greater than 4. That's this, starting at the 4 and going in the greater than direction. And then over here, I'd add 5. That cancels. Negative 3 plus 5 is 2. 2 divides into 2 one time. So this one is less than 1, which is this direction. So I've just got 3 more slides, sorry. And they're all my math lab examples of this stuff, which involves the greater than. It says, which of the following pairs of inequalities is equivalent to the absolute value of x being greater than 18. So remember, you're going to start with the x being greater than 18. That's one of them. X is being greater than 18, which is right here. X is greater than 18. Is that the only one? Nope, and this one too. X is greater than 18, so it's one or the other here. But then you have to reverse it, and the other one's going to be x is less than a negative 18. You're going to change your greater than to less than, and the 18 goes to negative 18. They both switch signs, if you will. So, okay, am I the only one seeing this? Those C and D are the same damn answer, aren't they?
Uh-oh.
One
Oh, wait.
and one is an or,
There we go.
and the other is an and.
Exactly. I wasn't even picking up on that, and now I see it. One of them's an or, and the other one's an and, so which one is it?
D?
Nope. It's the or.
Oh, okay.
Go back. It's okay. If you go back up to the theorem, it has the word or in it. Highlighted in pink right there. These are ors. The in-betweenies are the ands, but they never use the and. But this one's an or. So it would be C. It's an or. It's one or the other. Because if you looked at the number line, here's 0, here's negative 18, up here's positive 18. You can either go to the right or to the left. You can't do them both at the same time. Whereas an in-betweenie, you know, an in-betweenie would be, come on. An in-betweenie would be going in both directions at the same time because it's in between. So this technically is an and this over here, the pinks, those are your ors, because you can either go to the right or go to the left. You can't at the same time.
Okay, got it.
Okay. And this one, okay, solve the inequality. Again, it's another greater than. So I'm simply going to start with the actual inequality of 4x minus 6 is greater than or equal to 3, or the 4x minus 6 is less than or equal to negative 3. And now I got to solve both of them. I'm going to add 6 first to cancel those out. Oh, man. Let me get a fraction. All right, so the first one is x is greater than or equal to 9/4. Not pretty, but I'm going with it. And then the other one, I'll add 6. I get 4x is less than or equal to 3. Divide by 4. And x is less than or equal to 3/4. So that's my answer. Let's see. There are finite many solutions. There's always infinite many solutions. There's just always infinite solutions on these because you keep going and going and going in both directions. And you have all the fractions in between, and fractions can get infinitely small. So whether it's an in-betweenie or it's an or situation like this, it's always going to be infinite. Always, always infinite. So I'm going to click on this, and the solution set is, okay, they said type your answer in interval notation. All right, these are 2 separate intervals. The one I circled in green, I'll start with because its x is less than or equal to 3/4. I'm going to start with this one here because that one starts, the smallest value is negative infinity, comes up to the 3/4 and includes it. The red one is a totally different inequality, and it actually starts at the 9/4 and goes to infinity. Now, this didn't say anything about putting a comma in between. That's because when you're dealing with more than one interval, you have to use this symbol right here, which looks like the letter U, and that actually means a union, meaning everybody in this interval and everybody in that interval together in one big happy family. So make sure there should be in the toolbox, you know, like on your computer keyboard, you only have greater than and less than signs. So you're going to have to use the toolbox. Let me finish this and I'm going to pull up my math lab real quick and I'll show you what I'm talking about. And now we're looking at the correct answer. Let's see, were these equal tos? Yes, brackets at 3/4, brackets at 9/4, going in opposite directions. That's going to be choice C. The green one here, this looks to be about 3/4 and it's going in that direction. And this is 9/4, which is what, 2 1/4? Yep, going in that direction. So it's choice C. Let me go to Pearson, sign me in, find Ivy Tech, section. Can you see all this okay, what I'm doing? Can you see my math lab?
No.
So it's still on the PowerPoint.
Okay, let's see, stop share. And share screen. Where'd my math lab go? There it is. Now, can you see it?
Yes.
What question were we doing? That was number 19. Okay. Number 19, this only shows 15. Did I type something wrong on that? Maybe I typed 19, I meant 15. Okay. What problem was that? I typed 19 on it, didn't I? Oh, 11 April. Where the heck did I see 19 from? I don't know. I'm losing my mind. Number 11. Boop. Okay. This is a totally different question, isn't it? 4x.
No problem. No problem. It was popped up. Oh, it's still on the question screen.
Really? You can't see
Or the
the...
do homework type of screen in the 15 questions.
Really?
Yeah.
Okay. That is so weird. How do I share the whole screen? Okay, well, let me try again. Where is it? Now can you see it?
Yes.
All right, cool.
Now we can see it.
Okay, and this one's a little different from the one in my PowerPoint because it must have regenerated on me because I probably forgot to save the stupid thing. So let me figure it out real quick. That would be 4x is greater than 13. So x is greater than or equal to 13/4. And then it would be 4x minus 7 is less than or equal to -6. And I'd add 7. So I'd get 1. And then I would divide and I'd get 1/4. So it's infinitely many solutions. Type that in. Okay, as soon as I hit my box, do you see it popped up down here, the little union symbol? And so for me, it's going to be parenthesis negative infinity, comma, 1/4, put in the fraction button, 1/4, scroll over. It's an equal to, so I need a bracket, which I have on my computer. There it is. And then I'm going to click union. And then I need another bracket going that way. Whoops. And then another fraction. My other answer was 13/4, comma, and infinity. And then parenthesis for that. And then check answer. And I better get a positive affirmation. Well done. And then the next part pops up and there's my multiple guess. And these are in opposite directions, 1/4 and 13/4. And it looks like G. Do y'all concur that it's G? Check answer. Fantastic. Woohoo! All right, so I am done. Let's see, I stopped shared. Does anybody have any questions?
What is the upside down
Oh,
union sign for?
that's called intersection, but we do in-betweenies, so we're not doing intersections. We don't need the intersections for this section at all.
Okay.
Okay. Anything else? Going once? Going twice? All right. As usual, it takes like 20 minutes for this video to generate itself, and then I'll put it in my YouTube channel, and then I'll post the link in, well, it'll be in Ivy Learn, my YouTube page, and you just have to look for my playlist. There we go. And then I'll save the PowerPoint that's edited also, or I did all my writing all over it, and I'll post that in Ivy Learn. So if that's it, nobody's got any questions, I'm signing out. Bye. You guys have been a wonderful audience. Tip your waitresses.
Then see you on Monday.
Okay, bye. Have a good weekend.